Good morning, Stanley Lake Gators. Mr. Blackman coming at you on this fine Tuesday morning. Hope you've been enjoying the weather. Hey, if you're going out in public and so forth, just a reminder, just to grab that scarf, bandana, anything that you have. Remember, this isn't for my protection. It's to prevent me from spraying and potentially spreading contagions into the environment. So this is going to be the new norm, just like this classroom is that we're doing right here. All right, so without further ado, we are jumping into lesson 4.3, which is on page 191. And just to recap, in 4.1, we did the product and power rules of exponents. The power rule, where if we're multiplying two exponential expressions, that we're adding the exponents. And then the power rule is when we had those parentheses and that we're raising an exponential expression to a particular power. Now remember, the whole idea of exponents, repeated multiplication. So we've done the expanded form, but we realize that we don't have to write x 50 times necessarily, that we can apply some rules. Then we did the quotient rule in 4.2, and that's when we're dividing expressions that have exponents, and there it was subtraction. So we've had addition, multiplication, and subtraction. Now we're going to jump into two more concepts. And what we're looking at here on page 191, 4.3, is we're looking at the zero and the negative exponents. Now we've had a little bit of exposure to this, but let's talk about back in 4.2, we had x to the a power over x to the a power. And we got to find a marker that works here. Now, if you remember, we talked about the concept of 1, that any quantity divided by itself is equal to 1. Well, that would be no different right here. X to the a power divided by x to the a power does, in fact, equal 1. Now, we can apply our shortcut that we know about the quotient rule, that's division, is that we're going to subtract our exponents, so that if I have x and I'm going to do a minus a, well, then we are going to get x to the 0 power. X to the 0 power, we just found by definition, is equal to 1. All right, so I am going to scroll here. Let me go ahead and get rid of this right here. All right, so let's take a look at a couple examples here on page 191. That this first expression right here, we're going to do it old school here, where we're going to do the expanded notation. It's 2 to the 4th divided by 2 to the 4th. So that was 2 times 2 times 2 times 2, all divided by 2 times 2 times 2 times 2. Okay, we have the exponents there, and we're going to make these expressions of 1 so that we can see that, in fact, that does equal 1. So that if I had 2 to the 4th power minus 4 is equal to 2 to the 0 power, which is equal to 1. Okay, now we're going to do it using our rule, the quotient rule. We're subtracting our exponents because we're dividing. So in this case right here, I have 5 to the 3rd divided by 5 to the 3rd. So I'm going to do 5 to the 3rd, and we're going to subtract the exponent from the denominator, and that's going to give me 5 to the 0 power. Now, instead of drawing it all out, anything to the 0 power is going to be equal to 1. So 5 to the 0 is equal to 1. All right, we're going to keep motoring on here. Let me erase, and we're going to scroll. Let's see what I just did. Okay, so that was the concept of the 0 exponent. Anything to the 0 power is 1. Now we're going to look at negative exponents. Now in 4.2, when we were working through the quotient rule, some of those problems did leave us if we applied the rule of subtracting the exponents, that sometimes we ended up with a negative. So we went a little bit over that, but let's go ahead and expand it a little bit more. So what we're looking at here is we are going to I like this one right here. So we have x to the 3rd. So in the directions it says let's try with the expanded form first and then applying the rule. So I have x times x times x all over x times x. Now again, our concept of 1, x divided by x is 1, x divided by x is 1, x divided by x is 1. We are left over with 2 x's in the denominator. So no x's up here, but I do have to put a 1, and then I have x squared. Now we can take the shortcut. In this case, y to the 4th divided by y to the 8th. We're going to use subtraction, and we are going to get y to the 4th minus 8, because I'm taking the exponent in the denominator, subtracting it from the expression in the numerator, and I'm going to end up with y to the negative 4th. Now, if you remember, if we did it like this, what happens is we are going to write this as y to the 4th. So if you have y to a negative exponent, we can rewrite that as 1 over. Let's do one more right here. A to the 7th divided by a to the 10th. And if I do subtraction, I'm going to get a to the negative 3rd. 7 minus 10 is negative 3. But we're going to rewrite that as 1 over a to the 3rd. So to summarize this right here, a few sentences describing it is really that when we have a negative exponent, what we are getting is we are getting the reciprocal. We're getting a flip of that exponential expression, and you're writing it as 1 over. So anytime you see a negative exponent, if the negative exponent is in the top in the numerator, we're going to move it down to the denominator, and vice versa. If it's in the denominator, we're going to move it up here. So basically the word that I'd like to say uses reciprocal or a flip. That's really what we're looking at when we're talking about negative exponents. All right, let's go ahead and do some practice problems.